undoing a chain rule, basically. So you're gonna have something like, let's start here. Can you calculate the derivative of f?
Yeah.
Negative 7 x squared times 2x.
Okay. So we have it as a chain rule, right?
Right.
So how would you get back to the original function?
Would your u be x squared?
Yeah. Right.
Then
You need to think in terms of chain rule, right? So you have, this is going to be in the original, right? And this is your added on chain rule. Okay. So what we need to do is manipulate this so we can get rid of the 2x. Correct? Okay. We know that x squared, the derivative is 2x. So that's how we're going to manipulate this. Okay. So if we have some function, recognizing that we have a chain rule derivative here, u is x squared.
Right.
Okay, what's the derivative?
2x. Is it dx as well?
Yeah.
Flip the other way and switch it to du.
Right. So what we need to do is get rid of this and plug in du.
Yeah.
And then we're also going to substitute u for x squared. So you got two substitutions there. All right? And the rest of it stays. Do you want to okay. We have a couple choices here. We can leave these as they are, the integer limits, or we can change them. Because right now these are in terms of x, right?
You put it to u, the original.
Okay. If we change these to u,
Hey, since when was that a thing?
it's always been a thing.
Yes,
We are in terms of u now,
Yeah.
so we want to change those to be values of u. So if 0 is x,
0.
u
Oh,
is
you just-
0,
Oh.
right? And if 1 is x, u is 1. So they don't change.
So if it was originally 0 to 2, when the U sub would be 0 to 4.
Right.
I see.
Yep. Okay. So now you've got a very straightforward integration problem. Right. So what is the antiderivative of negative sine u? Cosine u, evaluated from 0 to 1. Okay. So that's a definite integral with u sub.
Wouldn't it be cosine 1 squared minus cosine 2?
No, see, that's the beauty of changing these.
You don't ever have to
It's
bring
u
back-
now, right?
Why is it negative?
What's the antiderivative of sine? Negative cosine, the opposite of that. Okay. So yeah, that's the beauty of changing these, is that you don't have to worry about changing it back to x squared. Let's look at when we would have to move it x squared. It's an indefinite integral, correct? So we do all our U sub. The antiderivative is correct. But we have not done any manipulation of the integral limits because there are none, so we have to change this back in terms of x.
How often is there that, or you, wow, I can't answer. How often do you have to do a indefinite integral U sub?
It might be a multiple choice question on the exam.
It wouldn't be a,
I doubt it. I think this pretty rarely comes up as a free response.
because there's rarely indefinite integrals and free responses to begin with, right? Because it's all application.
A lot, well, yeah, you're using your derivatives a lot. They do ask for some direct calculations of integrals and derivatives once in a while. So, all right. Let's see. How about?
Hey, you.
It's such a strong four-wheel.
So you
Here's
use
this
the
area.
yeah. X squared plus 9.
Okay, so you have,
So bad.
yeah, so you should just recognize this is a chain rule. Right, here's your original, and here's your derivative. Now there's no, this is, the derivative here is 2x, right? There's no 2, we're gonna deal with that. But,
This one gets stuck in the front. But
so u is x squared plus 9. And du is what?
I feel like I always dropped the constant in these last year. I don't know why.
you need to write it out, but
What's du?
2x was
2x?
5x².
Yeah, these need to match.
Oh, so you have to do one
We
half.
have to divide by 2, yeah.
You put it out in the front and confuse that.
I told you.
Remember that in our life last year?
Excuse me. Well,
All right, what do we got? U to the
6 divided by 6.
6 times 2 is 12, right?
Sure.
You okay with
Yeah.
that? And then plus c. And it's indefinite, so we have to plug in
X squared plus 9.
again. How do you know, how can you check your work?
Derive that.
Yep. Calculate the derivative. It should get you back to that. Gross.
Wait, when you derive that, it's just a chain rule, like,
Yeah, it's not that, but
I was
It's
pretty
a chain rule problem.
When there's a constant in the numerator or denominator, it doesn't matter, does it?
No. We'll
actually
follow.
when there are square roots anywhere in these, do you think we're okay?
Let's see what more if we can.
Oh, nice. Maybe like being hunted by some serial killer before, so maybe you make that noise and gonna take a person back.
That is
Serious better make that noise.
Because he hates that noise.
It sounds like a forest.
Do you recognize?
That's an identity.
No, it's not.
Oh, that was
Tangent
gas.
two, right?
Yeah, so is there a derivative here
Oh, yeah.
of another?
Tan X is.
But the
The
Q.
derivative of tan is,
Oh, so you just have U.
Right,
Never
so-
mind, that makes sense.
yeah, your u is tangent, theta. Means your du
I
is,
think I think U has to like have something happen to it.
right,
Wait a second. What about that cube there, the, sorry?
It becomes U cubed. You don't have to get rid of it. That's
So
just
you
a-
don't worry about it.
Yeah,
Why?
yeah, that's exactly what I'm like, wait, no.
And then, what's nice here is that we substitute this whole statement out. It's gone. So just recognize the chain rule there as a function and its derivative in the same one, chain rule. You said it. Okay,
10.
the integral limits, easiest to sub out, right? What's tan at 0?
1.
Oh, 0.
0, because it's sine over cosine.
Oh, I got that wrong in the quiz.
Sine
Say
at
that's
zero.
right.
Sine at 0. Right, sine over cosine. Sine at 0 is 0. That's
Well,
it.
it didn't matter though.
And then, but tan at pi before is 1. Now you can just do your math.
Somebody get to redo the quiz.
No, it didn't matter.
Dunzo.
Because even if you think tan is cosine over sine, at pi over 4 is 1. Because it's root 2 over root 2. So if
Oh,
you
okay.
you did that, your answer would be 1.
Yeah, okay. I was like,
Oh, I have.
You're great at an answer.
Okay, you try these problems. If you're struggling on Tuesday still, you can take a look at it again.
What was the biggest weak point from last year that we had?
this.
Nope.
Really?
Effort.
I want to get it. Something like a content piece.
You guys struggled calculating basic derivatives as a class.
That was.
And nobody would come and get,
I went, yeah.
oh,
And
your attitude's soured pretty bad. I don't know. For my part, I just kept my foot on the gas pedal because I wasn't gonna get the satisfaction of letting you quit.
Yeah.
You know, I mean, for my part, this year I'm taking it a little easier. If we're having an issue, there's a lot less issue with effort this year. But if we're having an issue with something as a class, I've stopped and taken a day to address it, which I did not do last year. So, just
I feel better organization.
Aren't the seniors in your calc class this year actually attentive?
yeah.
Because I feel like we had the worst seniors last year in our calc class.
Yeah.
As far as that effort portion.
I'm pretty sure they got the year it's like the second week of the school.
Yeah,
year, so.
I'm pretty sure
Yeah,
they
it's October.
Yeah.
Yeah, I don't know. Hard to say. Some of the juniors weren't very good either. It was just it was hard, I don't know what to tell you. Bad attitudes. What's done is done. Just fix it, or in front of you, fix it.
Ready to challenge?